from here, I'll go ahead and run the simulation. Within the simulation, you should set it up, make sure that your end time is where you want it to be, and I pretty much use the default options. You can try different ones. And here I run the simulation. Because I've run it before, things are showing up on the screen where I've placed my probes. There is some aliasing that you'll notice that occurs when the simulation is occurring in live time. Not everything is being shown. But then while the simulation is running, you'll see the sim button on the screen. And then when the simulation is done running, you'll see that the aliasing goes away. So here we have our frequency starting low and increasing higher and higher. And up until we get into the 10 kilohertz range, the signal is passed without any filtering. And then by the time we get to 20 kilohertz, now we have a much reduced output. So this is showing the filter working as expected. If you want to look at different things, when this first comes together, these positions are the same. So both of these will come initially at 0 position. But if you want to be able to separate your signals, you can't type in here, it looks like. You have to use the arrow keys, which is fine. So let's take our channel 2 and move it down 20 notches. And take our channel 1 and move it up 20 notches to separate those signals. I had done that previously off camera. You can change the time per division on the view, so we can zoom in on certain aspects. And then you can also slide your start time to look at different parts. And then once we get into more of the filtering, we can get our zoom and then zoom in closer and closer. So once the simulation is run, you can browse through different times in the simulation by dragging the slider here. Let's go to near the end of the simulation, and you can also use the arrows to move left and right in addition to dragging. At this point, since we have attenuated channel 2 quite a bit, we can change the volts per division to get a better view of that. We can also still change the horizontal time per division as well. And let's go to the very last cycle, and you'll notice we have a cursor. The cursor can be turned off or back on. And we'll get a rough idea here. So we have 125.67 millivolts is the peak signal here, and 125.6, 125.9. Okay, so we can get an idea of how much attenuation we have. So 125.9 millivolts plus 125.67, so that's our peak to peak level in millivolts. Divide that by 1,000 to get it in volts. We know that our input signal is plus and minus 2 volts, so that's 4 volts peak to peak. So that is our gain, and taking our gain, we'll take the logarithm of that and multiply that by 20, and that is our gain in dB. So at our maximum frequency here of 20 kilohertz, our gain is minus 24 dB. We can compare that versus the filter design parameters, and we can see here at 20 kilohertz we'd expect to see 24 dB or negative 24 dB of gain or 24 dB of attenuation. So the simulation in the time domain lines up with the expected results in the frequency domain, and so the next step will be to actually build this circuit and test it.